Hello. So we're going to talk about graph theory. Um, you've already dealt with graphs in trees and linked lists, but they have special constraints on them. And as always, we're going to look at the Carrano slides first. I find that the Carrano PowerPoint slides are a little faster and harder to understand, but in this case, they say the same things as the McAllister slides, and so we're going to look at the McAllister slides next. So just the first few things about graphs. Here's an example from Massachusetts, a few road maps, a road map of connecting various small towns. And in that graph, in that road map, it's a graph, and there are distinct vertices and edges. The circles are called vertices or nodes. The lines are called edges. And we also can talk about a subgraph being a portion of a graph. So here's a directed graph of a city street map. Now, when I go downtown to the office where I do some consulting work near Union Station, I usually use Google Maps to remind myself how to get there, but I often forget how to get home. And when I was coming home recently, we did not have this much connectivity in the street map of downtown DC. In fact, a lot of these roads were closed, which would mean the arrow was taken away. There was no connection between one node and another, and some of them were one way, as these arrows indicate, and so you couldn't get up this road. Anyway, I went all the way north to the Beltway before I finally figured it out. So let's talk about a few more definitions. A path is a sequence of edges between two vertices on a graph. Path from A to B, A to C, has to go through B. There are two kinds of graphs. There's a directed graph called a digraph and an undirected graph. So in a directed graph, you have to consider the direction of the edges. And in a directed graph where there are no weights on the edges, the length of the path is the number of edges that it comprises. So a cycle, also a definitional word, is a path that begins and ends at the same vertex. So now let's talk about a weighted graph quickly. A weighted graph just has values on each edge. And for this example, it's a mileage between towns. It could be a weight or cost, could be a weighted, as long as it has some kind of value on the edges, it's called a weighted graph. Another word is a connected graph. Connected graph has a path between every pair of distinct vertices. In other words, there's no vertex that's out by itself without a graph, without an edge between them. By the way, when you get to implementing a graph, you can't have an edge that's just hanging out. You can have vertices that are hanging out by themselves without any edges connecting them, but you can't have any edges that don't have at least two vertices connecting them. So here's an example of three different connected graphs. There are no, and then the third one, C, is a disconnected graph because the vertex down in the lower left corner is not connected to anything. vertices are called adjacent if they are joined by an edge. And so in this case, A is adjacent to B, but B is not adjacent to A.